So hello everyone. So in this class I am going to derive an expression for the electric potential energy due to the dipole. So placed in a uniform electric field. Here dipole is placing in a uniform electric field. Okay. See here I will consider a uniform electric field. So this is uniform electric field. See, electric field always starts from the positive charge and ends at the negative charge. Okay. So this is electric field E. Okay. Here I need to place a dipole. Okay. So dipole means it contains two poles. One is minus q charge, another one is plus q charge. Okay. So initially the dipole is placed in this position. So this position theta 1, it can be called as theta 1, and this position is theta 2. Okay. So this position it is called zero potential energy position. Okay. So and this one is theta 2. Okay. See, due to the presence of positive charge and negative charge, here there is a generation of one force. Okay. So here also due to the presence of positive and negative charge, here there is also generation of one force. Okay. So now, so need to write the statement for this one. So what is the potential energy of a dipole? Okay, due to the dipole. See, potential energy of the dipole means it is the total amount of work done in moving the dipole from zero potential energy position to the desired position, any desired position. Okay, so it is the work done in moving the dipole from zero potential energy position to the desired position. Okay, so previously from the first chapter, electric charges and fields, so we know the torque formula. What is torque formula here? So torque is equal to PE sin theta. Okay, so why we need to take a torque here? Why? Because here two unlike non-parallel anti-parallel forces will constitute a torque. Okay, so torque is equal to PE sin theta. Call this as equation 1. Now we are moving the dipole from this position to this position. We are doing the work done. Okay, so what is the work done formula? So work done is force into displacement. I will take it as small displacement. So small work done dW. Okay, so this is for the linear case, but here dipole is rotating. We need to take in angular case. So what is in angular case formula? So dW is equal to force, it will become torque. This one is linear displacement, it will becomes angular displacement d theta. Okay, so now call this as equation 2. Now put 1 in 2. Okay, it will becomes dW is equal to 2 means so PE sin theta into d theta. Okay, so this one is small work done. I need to calculate the total work done. So total work done becomes sub W is equal to integration of theta 1 to theta 2. So I will take it as outside for the PE, and integration of sin theta into d theta. Okay, so what is the integration of sin theta? So integration of sin theta is minus PE cos theta. Okay, so what are the limits here? So theta 1 and theta 2. Okay, so now W is equal to minus PE, so upper limit and lower limit, upper limit minus lower limit. Okay, so cos theta 2 minus cos theta 1. Okay, what is theta 1 value? So theta 1 value is 90 degree here. So theta 1 is 90 degree and theta 2 is theta. Okay, so W becomes so minus PE cos theta 2 value is theta minus cos theta 1 value is 90. What is cos 90 value? Cos 90 is 0, but cos 0 is 1. Okay, so finally we will get W is equal to minus PE cos theta. Okay, so this can also be written as W is equal to minus P dot E. Okay, so both are same only. Okay, so this is the expression for the potential energy due to the dipole placed in a uniform electric field. Okay, so thank you. See, now finally we got a, so W is equal to minus PE cos theta. Okay, so this can also be taken as, so U is equal to minus so PE cos theta. Okay, see, based on this expression we will get a three special cases. So first one is position of stable equilibrium and position of unstable equilibrium and position of zero potential energy position. Okay, So this one is, we will get a stable equilibrium when P is parallel. So when we can say P is parallel means when theta is equal to 0 degree. Okay, so what is cos 0 value? So cos 0 value is 1. So you will get U is equal to minus P. Okay. So now for unstable equilibrium, so P is anti-parallel. So when theta is equal to 180 degree. Okay, what is theta? Cos 180. Cos 180 is minus 1. So you will get U is equal to minus, sorry, not minus, U is equal to P. Okay. So next one, for the position of zero potential energy position, so it will becomes for perpendicular. For perpendicular, that is theta is equal to 90 degree. On cos 90 value becomes 0. So that is U becomes, U is equal to 0. Okay. So these are the three cases for the potential energy of a dipole placed in a uniform electric field. Okay. So thank you.